this video we learn about some different type of things that is known as uh, couples. What is called couple? Couple. So couple means this type of thing. Suppose this is an object here, and some force is applied in this direction, that is the F force, and another same equal force is applied in in this direction, in this way. So there will be some rotation will form. So the definition of couple is that the two equal and opposite forces, you can see the two equal and opposite forces acting on a body but in different lines. So this is one line, this is another line. So different lines of action actually, so forms a couple. So a couple acting on a body, you can see in this picture, and when a couple acts on a body, the body is in translational equilibrium but not in rotational equilibrium. So thus couple is the couple rotates the body. Okay, so if you understand this one, so this is the center, and if we apply this force this in this direction, so the object will start to rotate. So some examples of couple force are like a tap is opened or closed when your fingers applied to couple it. Okay, the lid or bottle is opened and closed when your finger applies to couple it, and like a driver applies a couple with his hand on a steering wheels to run the wheels on the vehicle. So that means what is the meaning of the couple? So this is a circle, so I am applying a force in this direction, so you can understand this will start to rotate. So one force is applied in this direction, other force is applied in this direction, the object will start to rotate. Okay, so that is the thing couple. Next one we learn about the moment, the principle of moments. Principle of moments. What is this principle? So suppose for that I have to draw one diagram here. So now this is one thing, an object, and this is the force acting in this side. That one is F1 is equal to mg force, and another force is F2. F2 is working in this direction, F2, and in this particular point this is balanced here. So this distance is d1, this one is d1, and this one is d2. So this is P, this is R, and this one is Q. So this is the F. So now you can understand that in this case some torque will be produced, one in this side, another one in this side. So to balance this one, so this is the one torque, this is another torque will produce. So balance these two things, that both the things will be like equal. Okay, so moment means what? The moment of the force is this is called the fulcrum, this one. So F1 into D, it is this moment, and F2 into D, it will become this moments. Okay, so what you can write from here? You can write that as it is balanced, so there is a net is 0. So F1D, F1 D1 minus F2 D2 is equal to 0. So you can write F1 D1 is equal to F2 D2. F2 D2. Okay, so you can write anti-clockwise moment of force is equal to clockwise moment of force. So anti-clockwise moment of force is equal to clockwise moment of force. So this is known as the principle of moment. This is called the principle of moments. Anti-clockwise moment is equal to clockwise moment. Okay, so or you can write F1 by F2 is equal to F1 by F2 is equal to D2 by D1. It is also known as effort arm by load arm. Effort arm by load arm. Okay, so now next topic we'll discuss about the center of gravity. So center of gravity. So the definition of center of gravity. So center of gravity is defined as the point center of gravity center of gravity of a body is defined as the point where the whole weight, that means the gravitational force, okay, that is gravitational force of the body were supposed to act, okay. So that is called the center of gravity. So now we consider the object like this. So a different, there is a system of particles and different particles are there. So weight of this particle is W1, this one is W2, this one is W3, and so on like this way. This one is Wn, okay, W6 like this way, W6. So all the things will be added in a particular, one particular point. It will work. So this is called the center of gravity. So entire weight, center of gravity. This point is known as the center of gravity. Now, in the case of center of gravity, you can balance the object like this. So you can do in this line, the CG, this wedge. You can do like this in the case of center of gravity. So remember that the center of gravity of a body coincides with the center of mass of the body if the body is small in size. That is, the vertical height of the body is very less as compared to the radius of the earth, okay. This is because in case of small body, the value of g remains constant throughout the body, okay. So example of small bodies are like a blackboard, football, buildings. These are called the small body. In case of large body, like I tell you, so that is a body whose vertical height is not negligible as compared to the radius of the earth, that is called large body. The value of g is different in different points. Hence, the center of gravity does not coincide with the center of mass of the large body. So that is the thing called the center of gravity. So next one will come discuss about the moment of inertia. Moment of inertia. So what is moment of inertia? So moment of inertia is the moment of inertia or the rotational inertia of a body about a given axis of rotation is defined as the sum of product of the uh, mass of the particles and the square uh, of their distance from the axis of rotation. So it is denoted by I. So you can understand this one from this picture. So this is the axis of rotation, and this is one object here, and suppose the mass is m1, here is m2, m3, okay, m4, mn. So while masses of this distance are not same for all the cases, so this is the distance. This is r1, r2, r3, r4, and so like this way rn. So what is the definition I told you? The moment of inertia about the axis of rotation. This is the axis of rotation. You can define as the sum of product of the masses of the particles and the square of their distance from the axis of rotations. Okay, so I'll write down moment of inertia or you can say rotational inertia. Inertia of a body about a given axis of rotation. So this is also very important line, given axis of rotation. Suppose if I want to rotate this pen in this axis of rotation is this one, so we'll get some amount of moment of inertia. Now if I rotate from this axis, like I want to rotate in this way, in this axis like this. Okay, so the moment of inertia will be different. That means if the rotation is in this axis, you can understand how it is rotating. So then the moment of inertia will be different. So it depends on the axis of rotations. Okay. So what I written, their body on the axis of rotation is defined as the sum of the product of masses of the particles and square of their distance from the axis of rotation. So it is denoted by I, capital I, remember. So I will be how much? I is equal to m1 r1 square, m2 r2 square, and so on, plus mn rn square. In short form, in this way you can write summation I is equal to 1 to n mi ri square. So that is the expression for the moment of inertia. So now, what is the dimension of the moment of inertia? So dimensional formula, first you have to know that what is the SI unit of moment of inertia. So keep this easy. SI unit of moment of inertia, okay. So SI unit, we can say I is equal to what? I is equal to m r square. In the short form, if you write this formula, I is equal to m r square. So from here you can understand the SI unit will be how much? This m is kg and this one is meter square. So kg meter square is the SI unit. And what is the dimension? Dimension always you have to put in third bracket. So m L square T0, that is the dimension. So some factors on which the moment of inertia depends are the distribution of the mass of the body about the axis of rotations. So if you think about the wheel of the cycle wheel, so you can see the spokes also. So, but the most of the masses are concentrated on the rim. Understand? So that will give some different type of moment of inertia. And those who are like those cycles are used for racing purpose, there is no spoke on that type of cycles, so their moment of inertia will be different. So that is why the distribution of mass of the body about the axis of rotation it depends, okay, on the distribution of the mass of the body about the axis of rotation. And next one is the distance of the body from the axis of rotation. So you know that r is there, axis of rotation, the orientation and the position of the axis of rotation with respect to the body, and definitely the shape of the body. In this type of factors, the moment of inertia depends. So remember, what is the inertia? What is the meaning of inertia? I didn't tell you in the beginning. Inertia is the resistance. It depends on the mass. So in case of inertia, in case of linear motion, we studied about that inertia is the object inability to change its state from rest to motion. That is called inertia. So in case of moment of inertia also, when the object will start to rotate, and that is also when it is rotating, it is very difficult to stop. Okay, it depends on its inertia, and also sometime in the beginning, if the object is very heavy or something, so it is very difficult to rotate. Okay, when it is rotate, then it will come to the rotational inertia and stop. Then that is in a rest condition. So that is the mass of the body is a fixed quantity. However, the moment of inertia of the body is not a fixed quantity. It depends on the orientation and the position of the axis of rotation. So it I told you, can you memorize this one? So like, what is the physical significance of moment of inertia? Like, according to Newton's laws of motion, the body cannot change its positions of rest or motion unless some external force is applied on it, that you know. And this property of the body, by virtue of which it opposes or resists the change its state of linear motion, is called the inertia. The greater the mass of the body and greater the force required to produce the linear acceleration, thus the linear motions, the mass of the body is the measures of the inertia. Similarly, you can say that in the rotational motion, the torque is to be applied to produce the angular acceleration of the body. So, on the other word, the body rotating about an axis is unable to produce the change in its rotational motion by itself. So, this property of the body, by virtue of which it opposes or resists the change in state of the rotational motion, is called the rotational inertia, or in case of written here, the moment of inertia. Okay, so that's the moment of inertia. Like, it's a plays a very you can say that moment of inertia plays some role in the rotational motion as a mass does in the linear motion. So it's a very important topics. Now question is that there is one thing called the radius of gyrations. I tell you what is the radius of gyrations. So radius of gyration is the distance of a point of body from the axis of rotation at which if the whole of the mass of the body are supposed to be concentrated, uh, its moment of inertia about the axis of rotation will be the same as that determined by the actual distribution of the mass of the body is called the radius of gyration. So it is noted as capital K. It's called gyration. So we know this one, that I is equal to what? I is equal to m1 r1 square plus m2 r2 square plus, sorry, in case all the masses are same, we'll take, so this is m r1 m r2 square and then m r3 square, and like this way m rn square. I'll take common m and r1 square plus r2 square plus r3 square plus rn square. Okay, so if I multiply with the n and divide with the, so n into m, n is the number of particles, you can say n number of particles are there. So you can write r1 square plus r2 square plus r3 square plus rn square by n. Okay, so this n into m will become capital M. So it will become m, and then it will become r1 square plus r2 square, like this way, rn square by n. So this thing is called the radius of gyration. So you can write and compare with this one with you can write mk square. Mk square is equal to m, then r1 square. You can write I is equal to mk square actually. I is equal to mk square. So m r1 square plus r2 square, like this way, rn square by n. So k will be how much? You can write from here, k is equal to root over. So r1 square so that is known as the radius of gyration. So as it is the radius, the SI unit will be how much? SI unit will be SI unit is equal to meter, and dimension will be how much? Dimension will be m0 l t0. there is a dimension. So another formula you can write, so k is equal to, as you know that this one, I is equal to m into k square, so k is equal to, you can write root over I by m. That is also another important gyrations. So radius of gyration depends on the axis of rotation of the body. Okay.